Hi guys, welcome back to Unit 5, Section 1. This time we're going to talk about phase changes and what happens with different phases of matter. So you'll need your notes and you'll need Table S. We will be writing on Table S and labeling that. So the overview is that we're going to go and talk about phase changes, things called heating curves and cooling curves, and most likely asked questions. So when we talk about the phases of matter, we talk about our solids, liquids, and gases. So we have solid, liquid, and gas. Just to remind you, when we go from a solid to a liquid, we call that melting. Liquid to solid, though, is freezing, which is most of our time in Plattsburgh. Liquid to gas has several different names, so this can be evaporation, boiling, or vaporization. And going from a gas to a liquid is just condensation. Don't forget, back in earth science, you guys learned about two other phase changes. One goes directly from a solid over to a gas. That's called sublimation. And an easy way to remember this is that if you start with a solid, the word sublimation, the word solid begins with an S, and so does sublimation. So if you go from a solid to a gas, you begin with S's, so you begin with the sublimation. If you go from a gas to a solid, that's called deposition. And hopefully yours will be much neater and nicer on your paper. All right, so those are just the basic phase changes. And let's talk about kind of what those phases look like. So if I have a solid, I can show a particle diagram, which is those little particles all near each other and compact. When you have a liquid, those particles are just a little bit more separated. And when you have a gas, those particles are all over the place. All right, so those are your basic phase changes. And I want to show you Table S. Table S does show you that you actually have melting and boiling points here. Keep in mind that they're in Kelvin. Whoops. That we have them in Kelvin here. Oh, I guess my highlighter part isn't working. That's okay. We'll use this one. All right, there and there. So when you go from a melting point, let's make sure that we write that down just to remind yourselves. It goes from a solid to a liquid. That's also at the same temperature as going from a liquid to a solid. Same thing with boiling. Boiling, if we go from a liquid to a gas, that's at the same temperature as a gas to a liquid. So these temperatures for all the elements are going to be listed, and they're going to be in Kelvin, so sometimes they might ask you to convert it to Celsius. Go back to the temperature stuff, or just use Table T to help you do that. All right, so here's a heating curve. We want to show what happens to the phase changes at different temperatures. So we have our x and y axis. Our x-axis is time, our y-axis is temperature. And we show a series of steps. So make sure you get these steps right on your paper. We start out with an angled line, then it flattens out, another angled line flattens out again, and then another angled line. All right, let's label these as the three phases of matter. The first one, all the way down to the bottom, the lowest temperature is going to be the solid. Then we have liquid, and the ones at the highest temperature will be a gas. So essentially we're taking a solid substance and then heating it up, so eventually it gets to a gaseous state. And let's go ahead and do the particle diagrams. So the solid here, we can show these 5 little particles, all close and compact. And liquid, they're a little bit more separated. And in a gas, they're all over the place. Between the solid and liquid, we have a solid and liquid equilibrium. So that double arrow shows that equilibrium, and I've also shown it as this. So a solid to a liquid. It just shows that you have both solid and liquid particles there at that time. Same thing with the liquid and gas as well. So in a heating curve, we go from a solid to a liquid to show melting. And from a liquid to gas, we show evaporation, boiling, or vaporization. Just to remind you, it's the same stuff. It's the same temperature when you go from a liquid to a solid as freezing or melting. And then when you go from a gas to a liquid, that's at the same temperature for evaporation, boiling, and vaporization. That's just called condensation. So freezing and melting are going to be at the same temperatures for substance, and then condensation, evaporation, boiling, and vaporization are all going to be at the same temperature with another substance. So we'll talk about what's actually happening in these curves. especially with kinetic energy. So kinetic energy is when those particles are moving all around and they're just speeding all up. So when we go from a solid to a liquid, we have this spot here where the temperature is level. That's when the average kinetic energy stays the same. Okay, so same average kinetic energy. Because it's the same temperature, it's a level temperature, it doesn't change. Same thing here at this leveled line. Going from a liquid to a gas or vice versa has the same average kinetic energy. If we go from a solid to a liquid right there, that any of the angled spots, the average kinetic energy will increase. So I can even just draw a little key for myself. So we increase average kinetic energy. And then at those green spots, see if I can get that color back. Probably not. So anyway, the average kinetic energy stays the same with the green spots. Let's talk about potential energy. We talked briefly about that in the last lesson. It's pretty much just stored energy. So at the green spots, the average kinetic energy is staying the same or is level or is constant, but the potential energy will increase. So at both the green spots, potential energies will increase. At the blue spots, however, the potential energy will decrease because those particles are moving all around. Let's go ahead and sketch a cooling curve, and this time you're going to have to see me draw it. Unfortunately, I apologize. But it's still the same stuff as what we would have for a heating curve. So for a cooling curve, we want to make sure that we show time, or it could also be heat added. And on the y-axis, here we have temperature. So in the heating curve, we started with a solid. In the cooling curve, we're actually going to be starting with a gas. So we want to show that gaseous phase there, and then it will level off, and then go down to a liquid phase, level off again, and go down to a solid phase. So let's go ahead and label them. We have a gas here, a liquid, and a solid. So at this first level line, we have an equilibrium between a gas and a liquid. So it could be shown with those two arrows or just an arrow with two heads. And at the second level line, we have a liquid and a solid in equilibrium. This time I'll just show the two heads there of the arrow. So just to remind yourselves, it's still going to be the same phases of matter, or excuse me, the same phase changes. So when you go from a gas to a liquid, that's called condensation. And the opposite direction, that's going to be evaporation. I'm going to abbreviate that, boiling, or vaporization. Going from a liquid to a solid, there we have freezing. And from a solid to liquid, we have melting. So if you ever see a cooling curve, this time they just go down in their steps because you're starting with a gas and ending with a solid. Also to let you know, and this is a big thing just to make sure that you're all listening for this, you may only have part of this graph shown. So they may not show you the gas part, or they might not show you the solid part. So part of it might get cut off, and that's okay. As long as you know pretty much the lowest temperature, the first angled line would be the solid. If they're at the highest temperature, the first angled line is a gas. So let's go through most likely asked questions on any Regents exam. So here we have a heating and cool, or excuse me, we'll figure out if it's a heating or a cooling curve. Since we're starting all the way down at the bottom, and this is a solid, here we have a liquid, and there's a gas. This is going to be a heating curve because we're starting all the way down at the bottom with a solid for temperature. And they haven't really labeled this graph very well. So this is temp, and this can be time, or on the x-axis, or heat added. All right, so let's go through some of the questions added, and that will erase everything I've written out so far. So let's see. The first question is, what happens to potential energy during some sort of time? So say, for example, they said during times Q, to R, or from time 2 minutes to 4 minutes. So Q is here at 2 minutes, R is here at 4 minutes, and this is our what's happening in between. Since the line is level, we know that potential energy stays constant. So in this case, potential energy is constant. Oops, sorry, potential energy is increasing, I apologize. Alright, next one, average kinetic energy. Since the line is level, ooh, that was bad. Since the line is level, the kinetic energy stays constant. Potential energy will increase. I apologize. And again, that's for Q to R. Going back, if they talk about some of the angled lines, so say for example they said R to S. If we go from R to S, the average kinetic energy will increase, but the potential energy will decrease. What if they said from S to R, and they went backwards or down? You know S is at a higher temperature than R is, so the average kinetic energy will decrease. The next type of question is, what's the boiling or condensation point? So when they ask about any of the points, you're going to give temperature. Write that down right next to your notes right now. If they ask about boiling or condensation points, or melting or freezing points, they're asking what temperature. And this is one of the biggest things that people miss too, so make sure that you get that. So here, again, whenever you get a graph, label it, the solid, the liquid, the gas, and then from there, you'll figure out which one's boiling or condensation. So here, since that's the point right there, it's asking about which temperature. So at T2, whatever that might be, say for example it's 100 degrees Celsius. Its boiling and condensation point is, in this case, T2, or whatever temperature that they're giving you. And then same thing with the melting and freezing point. Since we know that this is a solid, this is a liquid, and that's a gas, this is going to be the melting freezing point between solid and liquid. So again, it's at whatever temperature that goes here. In this case, they say T1, they might say 0 degrees Celsius. Draw the particles during blank to blank. So in this case, they might ask you from P to Q. So if you have the line segment P to Q, P to Q, let's get rid of that. That line segment, we know that this is in the solid phase, so when we draw the particle diagram, we're just going to show those dots all close together. If they asked about T to U, and remember that's a line segment right above it, well, that's in the gaseous phase, so draw particles in the gaseous phase. Also keep in mind, they might ask you to draw 5 particles or 6 particles or at least however many particles. Draw at least that many, because if you do it correctly, but say for example they ask you to draw at least 6 particles and you draw 5, I can't give you credit. So make sure that you write out which ones they are. Now, say for example they had something at one of the segments, so Q to R, when kinetic energy is staying the same, we know that's between a solid and a liquid. They're in equilibrium. So in this case, you would draw some solid particles and then flip it to be some liquid particles. And draw those a little bit more around. All right. Okay, so when is a substance in the liquid phase only? So again, if we go through, that's a solid, liquid, gas. From Q to R is a solid and liquid in equilibrium. From S to T is liquid and gas in equilibrium. So if they want just the liquid phase only, it would just be this. So for that case, you could go from R to S. And what process is occurring during line segment blank? So say, for example, they said Q to R, that flat line right there. We know that from there, if we go in this heating curve, that is going to be melting. So we can say that that's melting. They ask about S to T. In this heating curve, we can say that it's vaporization or evaporation or boiling. If this is a cooling curve, then go in the opposite direction, of course. Follow whatever line segments that they're doing. And then what's happening to the molecules during line segment blank? So, for example, if they said line segment Q to R, you can say that the molecules are moving at not moving or moving at a constant speed, most likely they'll ask you when it's at a phase, when it's at a specific phase. So for example, from like T to U. During line segment T to U, the particles are moving faster, or the average kinetic energy is faster. So that's what they want to know, what's happening with the energy. All right, so to quickly summarize, x-axis is time, y-axis is temperature. Don't forget that the temperature is equal to the average kinetic energy, so that's the motion of the particles. And kinetic energy and potential energy will do the opposite things at that same interval. Hope you have a good day. Take care. Bye.